Agile Testing Strategies, testing approaches for Agile projects. In this video, we will explore various testing strategies that align with the Agile development methodology. We will cover key principles, quadrants, and specific techniques like test-driven development and behavior-driven development. Let's dive in. Core Agile testing principles. Agile testing is guided by several core principles. First, test early and often. Testing should start from day one and continue throughout the sprint. Second, continuous integration. Tests are automated and integrated into the continuous integration and continuous delivery pipeline. Third, the whole team approach. Testing is everyone's responsibility, not just the quality assurance team. And finally, testing quadrants, balancing business and technology-facing tests, supporting the team and critiquing the product. Agile testing quadrants. The Agile testing quadrants provide a framework for categorizing different types of tests. Quadrant 1, technology-facing and team support, includes unit tests, component tests, and application programming interface tests. Quadrant 2, business-facing and team support, includes functional tests, story tests, and prototypes. Quadrant 3, business-facing and product critique, includes exploratory testing, usability testing, and user acceptance tests. Finally, Quadrant 4, technology-facing and product critique, includes performance tests, security tests, and compatibility tests. The top row are automated and the bottom row are manual. The left column supports the team and the right column critiques the product. Test-driven development, or TDD. Test-driven development is a software development process where tests are written before the code. The process follows a cycle. First, write a test. Second, run the test, which should fail. Third, write the code to pass the test. Fourth, the test passes, refactor if needed. A simple TDD example. First, write a failing test. Here's an example in Python. Def test underscore some open parenthesis close parenthesis, assert some open parenthesis bracket 1 comma, 2 comma 3 bracket close parenthesis equals 6. Def test underscore some open parenthesis close parenthesis, assert some open parenthesis bracket close parenthesis equals 0. Def test underscore some open parenthesis close parenthesis, assert some open parenthesis bracket 5 bracket close parenthesis equals 5. Second, run the test and it fails. Third, write code to pass the test. Def some open parenthesis numbers close parenthesis, total equals 0. For n in numbers, total plus equals n. Return total. Fourth, test passes, refactor if needed. Behavior-driven development, or BDD. Behavior-driven development extends test-driven development by writing tests in a natural language that non-programmers can read. The structure is, given the context when some action is carried out, then a particular set of observable consequences should occur. Here's a behavior-driven development example with Gherkin feature, user login. Given I am on the login page when I enter a valid username user1 and I enter a valid password pass123, and I click the login button, then I should be redirected to the dashboard and I should see a welcome message. Here's the Python implementation with behave. At given open parenthesis quote I am on the login page quote close parenthesis def step underscore implementation open parenthesis context close parenthesis context.browser.get open parenthesis quote http://example.com/login quote close parenthesis. At when open parenthesis quote I enter a valid username quote open brace username close brace quote close parenthesis def step underscore implementation open parenthesis context comma username close parenthesis context.browser.find element by id open parenthesis quote username quote close parenthesis dot send underscore keys open parenthesis username close parenthesis. Continuous testing in the continuous integration and continuous delivery pipeline. The pipeline includes the following stages: code, build, test, deploy, and monitor. In the code stage, commit tests such as unit tests, static code analysis, and linting are run. In the build stage, build tests such as integration tests, code coverage, and security scans are run. In the test stage, system tests such as end-to-end tests, application programming interface tests, and performance tests are run. In the deployment stage, deployment tests such as smoke tests, canary testing, and blue-green deploy are run. Finally, in the monitor stage, production tests such as A/B testing, synthetic monitoring, and chaos testing are run. All these stages are connected to each other. Acceptance test-driven development, collaborative requirements definition. Acceptance test-driven development is a collaborative approach to defining requirements and creating acceptance tests before development begins. The process has the following steps. First, discuss requirements. Second, write acceptance tests. Third, implement features. Fourth, run tests and verify. And fifth, demo and feedback. The benefits of acceptance test-driven development. Ensures clear understanding of requirements between business and development. Creates living documentation that evolves with the project. Fosters collaboration between team members with different roles. Reduces development time by focusing on delivering business value. Builds quality into the product from the beginning of development. Test automation pyramid. The test automation pyramid is a strategy for implementing automated testing. The base of the pyramid consists of unit tests. These are fast, reliable tests at the function level with high volume and fast execution. The middle layer consists of integration tests, testing component interactions, with medium volume and medium speed. Finally, the top of the pyramid consists of user interface tests, also known as end-to-end testing with low volume and slow execution. Exploratory testing. Exploratory testing is simultaneous learning, test design, and test execution where the tester actively controls test design and uses information gained to design better tests. Common techniques include boundary testing, state transitions, error guessing, and risk-based testing. Session-based testing management. Charter, clear mission statement that defines the goal of the test session. Areas to explore, specific features or components to be tested. Time-boxed, fixed duration usually 60 to 120 minutes. Test notes, detailed documentation of findings and observations. Best practices and key takeaways. Some best practices for Agile testing include: implement proper test coverage across all levels. Automate tests at the appropriate levels. Balance automated and manual testing efforts. Use continuous integration for faster feedback. According to an expert, Agile testing is not a specific practice, it's a mindset. The best testers in Agile teams think differently about their role, working closely with customers and developers to build quality into the product from the start. Some further resources include Agile Testing, a practical guide, Ministry of Testing Community, and Testing in DevOps Handbook. Some key takeaways include: testing is a team responsibility, not just the quality assurance team's job. Test early, test often, and test continuously. Balance automated and exploratory testing approaches. Focus on faster feedback loops and faster recovery. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.